This is a nice question on circles and squares. So we're told that S is a quarter of the way from A to B, and similar for the other ones. Now, I'm going to need to use a circle somehow. So I'm going to put the center point in and then draw a line coming up. This will be half the length of the square. And I'll also go to S because I'm trying to use the information that I have. And I can also then draw in this line here. We'll have a right angle. Now, let's just suppose that the length of the whole square is 4. I can do this. It's just asking me which has the larger area. So I could call it 4x if I wanted to, but under enlargement, x can take any value. We'll still get the same, it'll still be the same whether the circle or the square is larger. So I'm just going to go with 4 here. That means that this length is 2. And then because this is also 4 and S is a quarter of the way of the long, then this is 1. Now that's why I went with 4, okay? You might not go straight for it. You might think, oh, I'll call it X, I'll call it 1. But once you kind of identify that we need to divide it by 4 to get S to, maybe I'll call this X, then it makes sense to use a multiple of 4. So the area of the square, therefore, would be 4 times 4, 16. Now if I focus on the circle, I need the radius of the circle, but I have it because I've got this right angle triangle that I've created. 2 squared plus 1 squared square rooted is root 5. Actually, I don't want r, I want r squared, so that's just going to be 5. The area of the circle will equal pi times root 5 squared, or 5, which gives 5 pi. Okay, and then we just need to work out which of these is larger. Well, 5 pi is approximately equal to 5 times 3.14. It's 3.1415 and so on, but it's approximately this. And as long as we're not really close to 16, we should be able to tell which one's bigger. 5 times 14 is 70, so this is going to become 0.7. And then 5 times 3 is 15, so this is actually 15.7. And the extra decimal places aren't going to make it up to 16. So therefore, we can see that the square has a larger area. Of course, working is required. You can't just say, oh, it looks like the square has a larger area because these look bigger than these. You need to ensure you do a proof along these lines.